Question 6. Find the domain of the function y equal 3x over x squared minus 25. Okay, solution for the question number 6. Remember, when you have one expression like that, p divided by q, the restriction is q must be different to 0. In our example, the function that we have is g of x is equal 3x over x squared minus 25. Okay, the expression x squared minus 25 must be different to 0. You set out then x squared minus 25 must be different to 0, and the negation of this statement is x squared minus 25 equal to 0, and solve this equation. Apply difference of square xx 5 plus or minus equal to 0. Therefore, the solution is -5 and +5. Then the domain of g of x is equal all real number except -5 and +5. Or another way to write the answer is in set notation, is x such that x must be different to -5 and x must be different +5. Okay, and corresponding in the handout of the option A. Okay, the question number 7 is find the domain of the function. And the function is y equal x minus 4 over x to the cubic power minus 64x. Okay, solution for the question number 7. The function is h of x is equal x minus 4 over x cubic minus 64x. Okay, again we have a fraction and the expression in the bottom must be different to 0. So the restriction is x cubic minus 64x must be different to 0. I don't like working with this inequality. I find the negation, que es the equation, and solve the equation. Of course, the solution for the equation are the restriction for our problem. So the solution for the equation are the bad guy of the domain of the function. Okay, this is factorial equation. Obviously, greatest common factor is x squared minus 64. One more time, we have a difference of a square here. You complete the factorization, open two parentheses, and square root this guy is x, and square this guy is 8, and plus or minus. Now the solution for this equation, apply the zero factor rule, is x equals 0, x equal -8, and x equal +8. Now the domain of h of x is equal, all real number except the bad guy, and the bad guy are 0, -8 and +8. Or another way to express this answer in set notation builder is x such that x must be different to 0, x must be different to -8, x must be different to +8. And it's not important the order. The order doesn't matter. In the handout corresponding with the option D. Okay, question A is again find the domain of the function. And the function is y equal square root 25 minus x. Okay, solution for the question number 8. The function f of x is equal radical 25 minus x. 25 minus x. Okay, entonces the condition is when you have a radical, when you have expression inside, the restriction is this expression must be non-negative. Okay, as in our example, this expression 25 minus x must be non-negative. This is the restriction. I'll solve with these inequalities. This is minus x greater than or equal minus 25 divided by -1, both sides, because I want positive x, no negative x. X positive is less than or equal 25. Okay, that's a conclusion. The domain of the function f of x is equal. Let me write in cell builder notation. Is x such that x is less than or equal to 25. They correspond with the option D in the handout. Another way to express the same idea in interval notation is from -infinity, 25 bracket. Question 9 is find the domain of the function. In this case we have y equal x over square root x minus 3. Okay, solution for the question 9. Let me copy this function. Let me assign one name, g of x. g of x is equal x over square root x minus 3. Okay, entonces this case is a combination. Remember, when you have a fraction, the expression in the bottom must be different to 0. And also, when I have radical any expression, the expression inside must be non-negative. Okay, so this example is a combination of both situations, fraction and radical. Because when you set up the restriction is radical x minus 3 must be different to 0, and the expression inside the radical, que is x minus 3, must be non-negative. Immediately, I convert this to equation. And it's a radical equation. But it's a super elemental radical equation, because when you square both sides, it's just x minus 3 equal to 0, then x equal 3. Actually, this is different. And the inequality part is x greater than or equal positive 3. Okay, so far, this condition, x different to 3 and x greater than or equal 3 is equivalent to say just x greater than 3, because it's obvious that this part and this part are a contradiction, right? Okay, so now final answer. Domain of our function g of x is x such that x greater than 3 is equivalent somehow to write 3, infinity in interval notation. And this is in the handout, the option A. Question 10 is find the value of for the function find negative f of x and f evaluate at negative x, and the function is f of x equal to x squared minus 5x plus 4. Solution for the question number 10. Okay, we have the function f of x equal 2x squared minus 5x plus 4. And first of all, I need to find negative f evaluate at x. Okay, this negative is only multiply whole thing by negative 1. In other words, it's change the sign of the entire equation. Entonces, minus 2x squared plus 5x minus 4. That's it. Super easy. In the second part of the equation, we have f evaluate at negative x. So this is different because it's evaluate negative, replace negative x in every x. Okay, we have in our equation it's 2 times negative x squared minus 5 negative x plus 4. Okay, entonces f evaluate a negative x is equal, okay, in this case negative x to the second power is positive, 2x squared, and negative, another negative is positive again, is 5x plus 4, and this is the answer. In the handout I asked specifically only the first part, and the solution of the first part is this, corresponding with the option B. That's it. Question 11 is find the value for the function and find f evaluate at x plus 1 when f of x is equal x squared minus 3 over x plus 5. Okay, let's see the solution for the question 11. Okay, we start for our function is f of x is equal x squared minus 3 over x plus 5. Yeah, I need to find f evaluate at x plus 1. Okay, this is our problem. Okay, it's just replace x plus 1 into the our expression. Entonces is x plus 1 is squared minus 3 x plus 1 plus 5. Okay, the only thing I need to do is, well, expand this using quickfoil. Entonces x squared plus 2x plus 1 minus 3 over x plus, yeah, I want to compute this, 1 plus 5 is 6. Okay, now f of x plus 1 is equal, again the fraction, we have x squared plus 2x, and subtraction 1 minus 3 is minus 2 over x plus 6, and this is the final answer, que corresponde en our handout with the option C. Okay, question 12 is for the given function f and g. Find the requested function and state its domain. And the first function f of x is equal to 6x plus 5, and the second function is g of x is equal to 6x minus 1. Yeah, I need the requested function is the division, f of x divided by g of x. Okay, solution of the question number 10. Okay, you have two functions. F of x is equal 6 6x plus 5 and d of x is equal 6x minus 1. And the requested function is f divided by g. Now you can represent like that, or you can represent like f of x over g of x. It's the same thing. Sometimes it's omit the x, but it's the same. So basically I set out who is f of x is 6x plus 5. And who is g of x is 6x minus 1. And you can leave it like that. Okay? And now I'm going to investigate the domain. One more time, we have a fraction. And you need to know that the restriction is the expression in the fraction, or the denominator, sorry, must be different to 0. Okay, one more time we convert it to equation and solve the equation. 6x equal 1 divided by 6, both sides, x is equal 1 over 6. Okay, so now the domain of f division g is equal x such that x must be different. The all real number is set 1 over 6. In this case, corresponding with the option, the correct answer is the option C. Question 13 is for given function f and g, find the requested function and state its domain. And the first function f of x is equal 4x to the given minus 1, and g of x is equal to x squared minus 1. And the requested function is the multiplication f of x times g of x. Okay, solution for the question 13. In this case we have two functions. The first one is 4x cubed minus 1, and the second is g of x is equal to x squared minus 1. And the requested function is f multiplication g. So basically it's multiplication this first function times this second function. Okay, so this is two binomial, you apply FOIL multiplication. This times this is 8x to the 5th power. Multiplication outer is minus 4x to the cubed power. Multiplication inner is minus 2x squared. And multiplication, the last, is plus 1. Okay, and this is our requested function. And see, I want to analyze the domain. Of f multiplication g. When you analyze this expression, okay, it is a polynomial expression. So this expression do not contain fraction or radical. It's the only potential restriction. No? In this case, it's obvious that the domain of the new function is all real number. All real number, because we have no restriction. Or you can write like from negative infinity, comma infinity.